Well, hello everyone. I'm Atharva Mehendale. I'm currently going to be presenting the Spring 2020 projects done by the external pedagogy team here, specifically in the infrastructure team. So we're going to first go into the first project we worked on, which was choosing the right notebook infrastructure. So what we wanted to do was build out a few Jupyterhub use cases, cost estimation models, and link a bunch of resources for instructors. There's a lot more information that is on the web page here. But this presentation will be covering what exactly I put on this web page, but feel free to click on it or visit it after this presentation. So the table of contents, just a quick summary of it. We're going over the deployment pathways overview, some cost estimates for both the littlest Jupyterhub as well as the Jupyterhub for Kubernetes. Then we're going over the resources section very quickly, as well as the frequently asked questions. So the summary, to just kind of start off, Jupyterhub is an open source service that creates these on-demand Jupyter Notebook servers. And this has really allowed Berkeley's data science program to deploy all this infrastructure with cloud computing. And one of its main benefits is that it really allows for the creation of standardized computing environments that are accessible through pretty much any browser. And this is cloud-based. So this is already pre-built infrastructure that allows a lot more rapid access to course content and more flexibility for computing standards. But we've found in general that really choosing the right infrastructure is very challenging, especially for new instructors who don't really know what the system is. So what we found, there are really two major sorts of implementations. Smaller class sizes, so we recommend the littlest Jupyterhub for, and the larger class sizes for Kubernetes. So now we're going to go into the deployment pathways, the way in which you can actually deploy Jupyterhub. So first you can use notebook services, and these are actually hosted for you. So what that means is cloud providers like Google and Microsoft actually provide these free notebook services that are hosted by different outside solutions. So the point of that is pretty much anyone can develop or run this code in browser very quickly. And these come with different pre-installed packages and has a lot of support for different languages. However, they don't really have a lot of the hardware setup or scalability customization that a few other options may offer. And they're more ideal for demos of different notebooks. So if you have a webinar that you want to do, or if you have a class that doesn't have very much needs, but you just want to set up a quick notebook, it's a one-time thing, it'd be really useful for them. So our recommended user size is under 30 people because it's not really built for much more than that. And there's an open source version called Binder. So you can see here Azure Colab, or for Google and Microsoft, but Binder's open source. Now, Jupyterhub for Kubernetes is a self-hosted solution. So what that means is it integrates Jupyterhub with a Kubernetes engine, and that makes it very robust and scalable. And what that means is it can deploy different containerized environments that don't cause you to be tied to any one cloud provider. It's a little complicated to set up, but you do get a lot of customizability, and it's very good for scaling. Now, what that means is the user size for this that we recommend is anywhere between 100 and 1,000 users. Basically, if you have a very large class or a very large set of people who are going to be using this, we recommend Jupyterhub for Kubernetes. This is self-hosted and open source, which means that this has a lot of great community support and also resources, which we will show later in this presentation. So for the littlest Jupyterhub, this is self-hosted. So this allows the creation of a very small Jupyterhub-like distribution on a single virtual machine. And so because there's only one virtual machine and the user size is low, as we say, around below 50 people, there's no real need for containerization here. And this is also self-hosted and open source, lots of community support and resources. Visual Studio Online is a Microsoft hosted solution. This powers different development environments and instances pretty much as they claim for pretty much any activity. And it does support working with Jupyter Notebooks natively if you want to. You can configure Jupyterhub to either be a central hub or just on a user by user basis. And this is pretty much up to 100 people. If you have a medium-sized group and you just want to, you want some sort of environment for them, it works perfectly fine for them. It's moderately scalable, but has a very fast deployment time if you're looking for that. Now, local Jupyter notebooks are pretty much, the original. They're all self-hosted. It's the simplest option, and that allows for complete customization of setup, as you can imagine. So what that means is you can run Jupyter hubs on your own server, and it leverages your own computer hardware for compute, which might be a problem, if it's too small. But if it's good enough, you might be able to just do that. But it's difficult to standardize these environments across students because there's no central hub for it, and there's no real hard limit on it. But as we said, it's a little more difficult to standardize that environment. And as always, for the previous couple options, it's self-hosted, it's open source. Now let's take a look at the different sort of pathway, like just comparing them. So when it comes to costs, Azure is free, but for Jupyterhub, for the latest Jupyterhub and Visual Studio Online, they have very specific pricing models. These are a couple examples of them, and you can feel free to look at the website for different cost model comparisons. On Jupyter, if you wanted to just do it locally, is also free. Now for customization, Azure provides a lot of different installed packages, and it provides language support across multiple different languages. There's no real scalability for hardware though, as we said before. You can use existing Docker images. There's a bunch of user resource guarantees for Jupyterhub for Kubernetes. You can customize a variety of different things is what we're trying to say here. And for the littlest Jupyterhub, it's a little bit less than Azure in that there are pre-installed packages, but there are plugins that you can put in that provide additional features. In addition, for Visual Studio specifically, it has a marketplace for different extensions that you can add in to customize your user environment. And it can run, as it claims, most user languages and frameworks. For local notebooks, as you can imagine, you can customize pretty much everything from the graphics, the user interface, networking security, pretty much anything. For the deployment process, Azure, as I said, has a fast deployment process, as in you literally just have to sign up online for this service. But for Jupyterhub for Kubernetes, you get set up with the cloud provider, then Kubernetes, Helm, and Jupyterhub, and potentially Docker, which definitely makes it a little slower. For the latest Jupyterhub, you need a cloud provider, a server, which is at least Ubuntu 18.04, which makes for relatively fast deployment. I was able to do it relatively quickly from the last time I remember. And for Visual Studio Online, since it's a browser-based version, it's going to be similar to Azure Notebooks. You can just sign up for it. And for Jupyter Notebooks, it's locally hosted, so that's going to be pretty fast. Now, as for the scale, Azure Notebooks has a 1 GB data limit and 4 GB memory limit per each user, and for each single user. But for Jupyterhub for Kubernetes, you can have a large group of concurrent users, but the computational resources at your disposal really depend on your cloud provider, so choose wisely. And we'll get to how you can really choose them. And so for the littlest Jupyterhub, you want a small number of concurrent users that it can support. So it's going to be relatively low maintenance to do it, but you want to make sure that there's going to be a small number of people on there. And for Visual Studio Online, that can be, as we said, any number of users. That's potentially 20 environments per plan. There are 20 plans per subscription, so you can support a variety of different users. And it just really depends for local Jupyter Notebooks as to their scale. Depends on how you want to use them. Now we can take a look at the cost estimates and different cost models for the littlest Jupyterhub. So before we start on that, I'll walk you through some assumptions and clarifications that the team made while kind of really understanding how to build out these models. So we came up with 3 dimensions that we're going to use to calculate this cost per user accurately. And that would be memory, or the random access memory, or RAM, then the CPU usage, and the disk space. Now, each different type of class and class size are going to have different needs, and that differentiates the amount of resources that are given to each one of those different types of cost allocation. And so for the 4 major options that we kind of came up with are going to be outlined through these 3 types. So small, which we classify as between 30 to 50 students. Then average size classes are going to be roughly 80 to 100 students. And large classes are going to be anywhere from 100 to 400 or above that. In addition, we came up with a few different formulas as recommended by the creators of the Littlest Jupyter Hub. So you can see that there. Basically, the point is to look at concurrent users versus and like multiply that by the memory or CPU usage and add a little bit of overhead, or total users in the case for disk size. Now, what they kind of estimated was that the maximum concurrent users should be roughly 40 to 60% at any given point, and normally 1 gigabyte serves as the maximum memory per user, with 128 megabytes being overhead for TLJH or other services that they choose to include in it. Now, based on our class sizes, using these formulas, we came up with 16 gigabytes for 30 students, and so on and so forth. 64 for 100, 256 for 400. And then what we did was we used these specific memory sizes to calculate the rest of the setup. So that would be 4 vCPUs and 32 gigabytes disk space for small classes. Basically what we did was we linked 16 gigabytes, found the best possible assortment of vCPUs and disk space, and those are the numbers that we came up with. So if you look at the chart for going across 4 different major cloud providers, we chose Google Cloud, Azure, AWS, and DigitalOcean. So there's a few different models here, as we saw across 4 of them across 3. So there are going to be 12 options here they could potentially choose from, and more if you want to investigate deeper. But we've roughly estimated that for the very small options, it's going to range anywhere from $130 a month and to $170 a month. And then the next option for average size classes is between $520 a month to almost $700 a month. And the most expensive option for larger classes is going to be from $1,300 to potentially $2,700. But feel free to take a look at our assumptions, see if you don't really agree with them or if you want to investigate them on their own. We highly encourage that. And we're going to do pretty much the same thing with Kubernetes in this case. A lot of the same clarifications are going to be here. So we pretty much have the same 3 types, the same 3 dimensions that we're going to use to calculate these. And what we realized was autoscaling is a key feature of Kubernetes and is a primary cost saver for them. Now, autoscaling is that it scales down at night and during weekends, essentially whenever your clusters just aren't as active, and it scales up based on your demand. And this is also semi-based on Berkeley's own Jupyterhub cost estimates, because the class Data 8 here at Berkeley uses Kubernetes. And so we linked this specific GitHub repo for that. Now, there are a couple of different formulas that we also came up with while investigating how they came up with their cost estimations. And so we realized that we could get the number of active pods as the total users divided by 4, and the recommended memory being 1 gigabyte times those number of active pods. So we saw roughly dividing by 4 is a good estimate for that number. And we pretty much had the same, as once we did that, we had pretty much the same sort of costs that we were looking for Kubernetes. About 8 gigabytes for 30 students, 32 for 100, and 128 for 400. And we use memory calculations for the rest of the setup, as you can see there. And it's pretty much the same thing. So definitely cheaper than TLJH, at least in this case, when you're doing it at scale. And that's the key part here. It's that you're doing this at a much larger scale. And so that can range anywhere from 64 a month to 85, and so on and so forth, 260 to 341, and then 1,000 to almost 1,400. Now for the resources, we link here a bunch of different ones for Google Cloud. So VM instance pricing, if you want to look into that. Then the free tier, if you don't want to pay more than what you need to. Let's say you're not using it too much and you don't want to pay for it, that's perfectly fine. And they have an option for that in the free option for pretty much all of these cases. DigitalOcean does have a 60-day free trial, not a fully free tier. So that's one thing to note. And then we did link a bunch of pathway guides. So for Azure, it's the website, signing up, documentation, how to create a project. Then for Zero Jupyterhub, it's more or less the same things, just really helping you get set up with these things, as well as for TLJH and use cases if you're not really sure if TLJH is right for you. Now we're going to go into some frequently asked questions. So first is, should I deploy my hardware in the cloud? We found that cloud is definitely typically easier because, especially if you don't really have much access to technical resources, because otherwise, handling your own physical infrastructure takes time and effort. So in general, cloud is just a lot more scalable and simpler. Is there a particular cloud provider that you can recommend? Please see your deployment pathway overview sections. As we said here, we recommend different ones for different scenarios and different types of use cases. But in general, if you have a cloud provider that you've worked with before, we probably would recommend going with that one since you already know how it works. And in general, basically, if you want to recommend two different options, as you mentioned initially, anywhere from 50 to 100 students, you want to go with the littlest Jupyterhub. And above that, probably Kubernetes. For hardware, that really is something you have to look into like in the previous sections, but we found RAM to be a major consideration in our calculations. So try looking at that one first. And just for the estimated cost, please see the table above. So in general, we came up with a list of like just technical considerations, challenges, and solutions. So for the challenges, we found, environment standardization to be very difficult. We don't recommend being reliant on any one cloud provider because that, it's healthy to just move from one to another. It's a lot easier to make sure that your costs are up to date. You're minimizing on that. Use open source tools. Like we found a lot more support for them. Then having team members with development operations skills, so hiring for them is actually pretty necessary, not just administrators, students, and faculty. For solutions, you want to be able to harness the cloud's power. So what that means is, don't really rely on physical infrastructure. We saw that that's just a lot easier. Then you want to abstract away any complex APIs and technologies for students. You want to use diverse and compelling real-world data sets. That helps a lot. As a student myself, I know that definitely makes me a lot more interested in the course and the materials as well. And as a student, we do have bursts of activity, especially around deadlines. And so you want to anticipate that, which is why Kubernetes is great because of its auto scaling on demand. Because of that, you're able to meet maximum demand. And in general, you want to have a lean, small team that is able to work efficiently and come up with, just handle any issues that come to hand. So for NB Git puller, this is actually a big core functionality of Jupyterhub and an advantage over a lot of different platforms. So what it does is it allows instructors to distribute content in a Git repository with one simple link. So as a result, students never have to interact directly with Git. So if they've never used it before, this is a great tool to use because they will never need to interact with it. This can work with Jupyterhub mainly, but also can potentially work with local computers. So if you want to get a look at the workflow, essentially just create the content, push the latest version to GitHub, share the link with the student, and then DataHub basically authenticates them, creates an instance for them, and then their storage volume links up to their Jupyter instance. They pull that content specified by that link into the student's instance, and they're now have a live in-browser instance containing that content specified in the link. So for customization support, we find that that's definitely a problem that comes up. How do I customize this environment for my specific need for my class? So we link here a specific page to 0 to Data 8. This guide basically tells you how to get really started with Data 8 or really any data science type class. And how can I find additional help? We recommend highly the Jupyter Community Forum. That's essentially your one-stop shop for any Jupyter questions. If you have any Jupyter questions, go to that one. That's the best one out there.